professor of chemistry working at Institute of Science in Nagpur. I'm going to discuss one of the one of the project of my student completed in the session 1914-15 submitted to university. The synthesis antimicrobial and antioxidant property of some novel flavonoids and pyrazolines from the charcoal. In previous lectures, we have seen how to synthesize the charcoal. So I will not go for the synthesis of chalcones, as you all are aware of how to get it from benzene chloride and terahydroxybenzaldehyde. So the main thing is that how to get flavonoids and pyrazolines. So these two are heterocyclic compounds. So the abstract of this project will cover how to get first chalcones, and then the chalcones converted into flavonoids, and then the flavonoids is converted into pyrazolines. So in this project we have designed and we have synthesized all heterocyclic compounds, and we have confirmed and characterized on the basis of different spectrochemical series, as well as we have evaluated their microbial activities against the different pathogens. So we will see here one by one what we have covered in this project. Okay, so you can see here we have to go through the literature review. So you will see what here. This is the structure of diamond. Means if you go through the structure, then we will see here benzene, and the second is not benzene, having the heteroatom and the carbonyl group. And if it is having here the C6H5 position number 2, and such skeleton is there, then we say what here flavon. Flavons is also said to be what here 2 called chromium dash 4 dash one. This is the correct name. Okay, and the common name is what here flavon. Flavon, iron, these are the common names. Then let's go through the literature. Then you can see here this is the one pyrazoline, two pyrazolines. On these things, nomenclature depends upon the position of the carbonyl group. Pyrazolines is what here the cyclic compound, the 5-membered cyclic compound having the nitrogen atom adjacent to each other, then we say what here pyrazoline. Isopyrazoline means when it becomes here imidazole, and not we will say here iso. When the molecule five membered ring having two nitrogen atoms separated by one carbon atom, then we will say here imidazole. So this is said to be what pyrazoline, in which the nitrogen atoms are adjacent to each other, one position, two position, three position. Here 1, 3. This is 1, 3. This is one position. Okay, one pyrazoline, two pyrazoline, one. This is one, two pyrazoline. This is 1, 2, 3 pyrazoline. So here these are the structure: one pyrazoline, two pyrazoline, three pyrazoline. One pyrazoline, two pyrazoline, 1, 3 pyrazoline, 1, 2, 3. This is 1, 2. This is 1. And let's go for the synthetic background of the earlier work. Okay, you will see synthetic background. This is the diagram here. This is the literature survey. So that the students has written in his project. Then let's go through. Let's move toward the synthetic background. How many researchers have done their work by taking the starting material, which type of starting, what type of skeleton is same. That is the alpha beta unsaturated ketone. You can see undergoing cyclization and gives the flavon type of structure. Flavon, that is bromine. You can see here two positions. Okay, four positions for carbon group, but that's why we say what here bromine. Okay, this is the structure that we have seen in first that is here bromine dash 4 dash 1. Okay, bromine dash 4 dash 1. So these are the different literatures. These are the synthetic backgrounds. But we have covered how many synthetic backgrounds to get what the flavins, as well as our project is based on the synthesis of pyrazolines and flavons. Okay, so these are the different methods available in the. What should be the plausible mechanism to get the pyrazoline? This is the plausible, which is available in the literature. We will go through the undergo, and then come to the point of what about its pharmacological activity here. Pharmaceutical activity, you can say whether they are active or not active. How, what parameters that we will use to testify this synthesized compound. Yes, on the basis of your pharmacological activity, your other methods are also given. That is the antioxidant activity. Do not require here living things. Okay, so on the basis of what your antioxidant activity, on the microbial activity, we will say the compounds are found to be active or not active. Okay, various activities are available. So what about the objective? Objective we have discussed in abstract of the project. Now we will go through the present work. Included about the synthesis of lamels, pyrazolines, antimicrobial activity, antioxidant in the last work synthesis, a confirmation of compounds, synthesizing compounds. Okay, so this the antimicrobial activity we have covered here. These are the battery dish, okay, indicating what zone of inhibition by the synthesized compound taking on different concentration in microgram per ml. That is ppm per ml. You can see here part per million. This is the will be the concentration. Then the experimental section of this project is having different section. Experimental portion of this project having different portion for synthesis of aldehyde and the second synthesis of ketone, as we have discussed in previous lecture. Then synthesis of chalcones. This is also we have discussed. The novel thing is how to get what here flavon. So this is the structure of the chalcone, and then we will go for what here the next slide for flavons. No, flavons. Flavons takes place in presence of DMO, so acts as a solvent, and I2. Without DMO, so the reaction is not possible. Typically, it requires here. Here we have taken here I2, and DMO so as a solvent will help I2, okay, to join hydroxy. That's why there is a role of DMO. So we have gone through this reaction. We got this one. We confirmed this product on the basis of different aspects. Four compounds we have synthesized. And the last thing is what here, how to get the pyrazolines. So you can see here the five-member structure. The skeleton, that is the chalcone is same, but pyrazolines is different. So different parameters we have covered to get the to confirm the synthesized component. Lastly, we have done what here antioxidant activity according to the published literature method, and we got here different data. On this different data, we can compare our synthesized compound with the our synthesis compound with the standard compound, and on the basis of that, okay, we say what here our synthesized compound is having both antimicrobial as well as antibacterial antioxidant activity. Both parameters we have. Thank you very much.